Welcome to part 2 of this little mini-series where we're trying to understand what the cool kids are talking about when they're talking about reactive programming. So, in all seriousness, what we're trying to do is that we're trying to build a library for reactive programming and possibly reactive functional programming in JavaScript. And again, we're just trying to keep it simple, take small steps, and build something that probably is reactive programming. So I'm going to assume that you watched the last video, and then we're just gonna jump straight into this, right? So, but as a quick recap, we're working in one single file. We've defined some general purpose functions that have nothing to do with reactiveness, but has rather everything to do with functional programming. And then we have this section where we've started to define some portions of our reactive library, or what will be our reactive library. And then we have this stuff in the end, which is just an example that we're working with, right? And the last thing we did is that we mentioned that we want to be able to build something like this. We want to say that you have some kind of observable, and then this observable, as you can see here down here, can start to emit a bunch of stuff. Maybe in order to put that stuff... it feels odd that we have that stuff in the end and then we have the observable up here. Maybe to make that a bit more logical, maybe we should do this. We'll put the emissions here, but we'll set a timer for that. So we'll set set timeout as function, and then actually let's just do it this way, like so, and then we'll call all of those at once. And I guess we'll call those after what? I don't know, 200, or it doesn't matter, 100 milliseconds, right? And then, so we have an observable that can observe or emit data, and this observable could be anything, right? That's the really interesting part about reactive programming. You can use it from anything from data coming from a server to mouse clicks on the web page, right? Or keystrokes that the user is typing. Anything can be thought of it as a stream, or as an observable. Maybe not anything. Anything can probably be thought of as that, but not everything can probably be thought of as that as an observable in a useful sense. But many things can be thought of as observables in a useful sense. And then here we have this double function. Actually, let's just abstract this away as well. Let's copy that double function, go up into the top, paste that double function in, and just rewrite that as this. Let's rewrite it as the function add. So the function add is a curried function that takes one x, returns a new function that takes a y, and then returns x plus y. Sorry, of course, I didn't think this through. We can't, of course, implement double as a partial application of add. What I meant was let's build mul, right? Let's build both of them actually. No, let's build the one we need. So let's call it molt actually, right? So molt is a function that takes one x, returns a new function that takes a y, and then returns the multiplication of x and y. Let me remove this double, which means that double could be implemented as this. Whenever we just say, instead of saying const double equals something, we could say equals molt, and then partially apply to 2, which means that whenever we apply the second argument, we'll double that argument with 2. Again, if I'm just assuming that you have some basic understanding of partial application, of currying and stuff like that, and if you don't, I highly recommend my series on Lambda.js. Not because it's specific to Lambda.js, but because that's a very practical way of being introduced to a bunch of these concepts. Let me actually put this back on one line as well, so that all these things sort of line up quite nicely. Okay, so now we've figured that out, which means that, double, we weren't actually ever using it in some place. Let me just search for it. No, we weren't even using it, so whatever. But okay, so what we were saying, then we were ending in the last video by saying that what we want to do is we want to be able to set up an observable, and this observable could be, now we're just faking some emission, we're assuming that it emits some kind of data, but maybe this is data that comes from the user somehow, or whatever. It stems from someplace, but in terms of our observable library, for now, it doesn't really matter where the data comes from, but there's some stream of data coming from somewhere. And so this we get the stream of data, but then we want to construct an observable that's sort of an aggregate, or that's sort of a composition of this observable that we had this initial observable that we have up here. Or rather, we want to take every item in that and then run it through some other observable. So it's like a composition of two observables, where this other observable is this sort of filter, right? And actually, I'm gonna switch away from filter, and we're gonna move to map, and then we're gonna go back to filter in the end, because filter is just a tiny bit trickier. I think it's easier to think about map. So because map is just saying that the only thing I want to do here is I want to apply some particular operation. And so the operation that we want to apply could be, for example, if I change filter here for map, vmap, for map, it could be something like when given some x, we multiply that x by 2. Right? So let's talk about that implementation, or let's use that implementation as an example. And this, of course, is what we said is double, right? But now we've removed the function double, so instead we need to say mult2, right? So let's say that this is our new scenario, right? We want to say let's say doubled, right? We want to construct a new observable which is called doubled, which is the result of piping all the results from this original observable into another observable that contains that is the mapping of molt over 2, right? It's a bit tricky to say this correctly. And then I'll rename non-zero here to doubled. Right? And of course this doesn't work because we have none of this code, right? Like our observables don't implement the pipe method, and we haven't implemented map in this way. Like this is a pipe specific map, or sorry, an observable specific map. Molt we do have, right? But the rest of the stuff we don't have. But yeah, so the reason we would do that is that what I want to get at is we could then do something like this. We could say observable, observable, can't spell, okay. And then we subscribe, and then maybe we just do console log. Right? So yeah, actually let's put that in the end here as well. So then we have the observable.subscribe, and then we push that out into console log, and then we say doubled subscribe, and then we push that into console log, right? So we have two observables, the original observable and the observable that's sort of based on the other observable that sort of doubles all of the original values. So maybe instead of calling that observable, maybe we should call that source. Right? Or like original, let's say original, right? But then I have to change in all of these places. Let's keep it observable, sorry. We have the original observable, and then we subscribe to that and we console log all the numbers, and then we have the doubled, and then we're console logging all those numbers. So I mean, if I try to run this, of course we get syntax errors, right? Fine, because we don't have a bunch of stuff. So let's comment out the stuff that we know that we don't have. Let's just see if we still have, if we're still in a place where this original stuff works, right? So that seems to work, right? But if we do both of these things, like if we implement the other thing, then we want to get not 10, 1, -1, and so forth. We want to get 10, 20, 1, 2, -1, -2, and so forth, right? Because we're doubling all of the values. And both of these observers are console logging, and both of these subscriber functions, both of these console logs are subscribing to the individual observers. So how do we get started with this, right? Let's think about that. Let's bring out this syntax again. Let's make this a bit easier. Let's maybe keep this commented and say, how could we express this in a more simple way? Or we could express this in a more simple way like this. Let's say doubled is an observable where, let's say we subscribe with a function that says that whenever there's a value, like we're just trying to think now about what we're trying to do, right? Whenever there's a value, I'm going to do something, okay? Let me actually put that back on one line. Whenever there's a new value, I'm going to do something. What am I going to do? Well, I'm going to take that value that I have, and I mean, trivially, what we're going to do is that we're going to say, run that function, run that value through molt2, right? But it's not all. That's not all of it, right? We actually want a new observer, or a new observable. So we actually want to say, I want to have a new observable, sort of, right? That. So let's say let O is a new observable, and then I'm going to say O dot emit x. No, the doubled x, right? So which is then molt2 on x, and then we're going to return O, right? Of course, then I have to do this in the end, right? So we're saying that subscribe. No, wait, what am I thinking about? This didn't work out. I mean, we can't use subscribe here because, yeah, okay, no. Yeah, this is even going to be, yeah, okay, so I have to use scope here. I was thinking that maybe this would be simpler, but it's not actually simpler. I mean, it's something like if I had defined the observable out here, observable, right? Maybe the doubled observable, the observable called double is defined out here. Then I could say something like that. I could say, okay, doubled should emit. Let me just hard code the calculation, right? Whatever x is given times 2, right? That's an okay implementation, right? This sort of now we're hang on. The cats just really like to destroy the couch, so they're taking whatever chances they have when I'm recording videos. Okay, so I mean, this is a very hard-coded solution, like a very, very hard-coded solution, but I think it does kind of what we were aiming for, right? Let's just see if we have syntax errors. That seems to work fine. So can we now subscribe to the second observable, which is called doubled? If I save and then let's run, yeah, that actually works, right? We get actually exactly what we were saying. We get first 20. No, sorry, we actually get it in the other order, but you know, who cares? We get 20 and then we get 10, we get 2 and then we get 1, we get -2 and then we get -1, and so forth, right? So we get both the doubled values and we get the non-doubled values, okay? So that's good, right? But this is very messy, this implementation that we have here, because we're essentially hard coding, right? And we're using the fact that we have, like, we're using, sorry, what is it called? Is a poor man's object. Closures are a poor man's object. We're using closures here, right? So yeah, let's not do this, right? So how could we simplify this? Well, if we stop thinking about the operation that we want to perform for a moment and just think about the fact that we're taking data from one source and we're making it data in another source, like we're sort of duplicating an observable. We're creating a new observable that sort of reflects this other data source. Then maybe pipe would make perfect sense, right? Because then we could say something like this, right? We could say, just take observable and pipe it into the observable double, let's say, right? So we're passing that in, right? And then let's just delete this, right? And actually, we're going to rewrite sort of exactly the same code, but yeah, I mean, simple. So let's delete that. So we're assuming that we have this other observable called doubled, and then we are piping the original observable. We are saying pipe on that, and then we want to pipe all of the data into the observable doubled. So how do we implement pipe in observable, right? So let's just say, okay, well, there's a pipe method. It takes some other observable. Let me just call that O. And what is it going to do with that? Well, it's going to do exactly what we did before, right? It's going to say whenever I emit something here, I should also emit that in the other observable O. So that just means we're going to say subscribe, right? We're going to subscribe such that whenever there's some data, I want to pass that data, right, to O, right? So I want to say O.emit whatever data I currently was given, right? Let me actually put that on one line. Maybe we don't even need, we don't even need those, right? We don't need the curly braces. Okay. So that seems fine, right? Let's just run this and see if that works. Yeah, that works, right? Of course, now we're not changing the data. Now we're sort of just duplicating the stream. We have two observables, right? So we get 10, 10, 1, 1, and so forth, right? But then we could keep going. We can have doubled, like let's say copy 1. Let's call it that instead of doubled, since it's now actually not doubled. So we have copy 1, and then maybe let's do copy 2, right? And then let's say we pipe both into copy 1 and we pipe into copy 2. And then we're going to say, okay, we're going to subscribe to both the observable and then to copy 1 and then to copy 2, and then we're going to console log for all of them, right? So now we have 3 times. We have every value 3 times. Okay, not very useful, but I mean, it seems like we're at least making progress. And of course, here we could also use the thrush operator, right? I believe. Let's think about this. Because we have some x. No, it's not that simple. Yeah, no, we can't use the thrush operator. But so now we can pipe, right? We can pipe the result of one thing into another observable. And now the only thing that we're missing is this sort of mapping. So what if there was another observable that did the mapping, right? Because we're piping everything into another observable. So what if there was an observable that actually did this operation? So then let's say, let's do that, right? Let's say there's a mapper, right? And this thing is also going to be an observable, a constructor, right? And if it's an observable, that means it's going to need the method subscribe, taking a callback. It's going to need the method emit, that's going to take an X that it needs to emit, and it needs to take it needs to have a pipe function. Actually, let's think about, do we need the pipe method? Maybe we actually do. Let's not, yeah, let's skip that for now, but I think probably we need that. But let's, I mean, you could imagine that these are following two, like you can imagine that the observable is following one interface, or that the observable is following two interfaces, and that the mapper is following just one of those interfaces, and that pipe belongs to the second interface. So let's keep it simple, right? Let's skip pipe for now, and then we'll see if we need that in the future. But what does the mapper do? Well, the mapper in its constructor needs to take some function, which is the mapping function, like which could be to double the value, right? To triple the value, to turn the value from a number to a string, from a string to a number, right? Or like any crazy thing, right? Any sort of operation that you want to perform on the basis of this, or with this particular value as input. So let's just save that function, right? We're saving away the function. And what do we do when we do subscribe? Well, to keep this, I mean, we could re-implement the idea of an observable in the mapper because it needs to be an observer, or an observable, or we could use with inheritance, or we could just use function, or composition, right? We could just compose objects to keep it very simple. So we could say, well, actually, I need to have an observable here, so I'm going to just say that it's a new observable, and then I'm going to manually emit to that observable, right? So then we're going to use this implementation that we have up here so that we're not duplicating the observable code in the mapper. So what does that mean? Well, that means that whenever you try to subscribe, you need to tell this internal observable that somebody has subscribed, right? So we're subscribing using this particular callback. And whenever somebody emits, you need to say that you need to, that the observable, sorry, I can't spell, inside needs to emit, right? It needs to emit this particular X, right? But this is just a regular old observable. There's nothing special about this. Let's get to that in a moment, right? But what I mean is that we could now do this. We could now say, instead, oh, sorry, actually, we haven't done this. What we could do is we could say, when we say pipe, yeah, that works, right? We have two observables, right? So we're passing in an observable to pipe. So instead of passing in observables here, we could pass in the mapper, right? Copy 1 is a mapper, copy 2 is a mapper, and then we're sort of subscribing to those, okay? So let's save that and let's run that. We should still get the same value, right? Because these are sort of, you can think about these as the identity operation. You could think about, if you think about functional programming, right? Our mapper now shouldn't really be called the mapper. It should be called the identity observer or something, or sorry, not observer, observable, right? The identity observable or something like that. That makes sense. It's like identity, it's like the identity data structure under the interface observable. But let's keep it as mapper, right? Because we're going to implement mapper. Let's just, before we do anything more strange, let's try to first get rid of this thing that we have in the end, right? Where it's like we have to specify copy 1 first and then say new mapper, and then copy 2 and say new mapper. What if we instead could say this? Const copy 1 is equal to the result of piping through, a new mapper, right? And then something like, and then the same thing in the second one. So const, okay, this line is replacing that line, actually those two lines, right? And then here we would also say, so const copy 2 is equal to the observable, or piping the observable by passing in a new mapper, right? That would be cooler, right? If we remove that, not just cooler, right? Obviously significantly better because we don't need a variable. Like there are fewer things to mess up. We don't need this intermediate variable, intermediate variable. So that doesn't work now, of course, right? This should blow up. Yeah, this blows up, of course. But how do we do that? The only thing we need to do is we should just need to say that pipe needs to return whatever observable it's been passed. So we're returning O here, right? So pipe takes some observable. It makes sure that whenever this observable rather, it subscribes to the inner observable, right? It's given some observable, and it's, oh, sorry, actually, I said we should return O. We shouldn't return O, because O is the inner observable. Sorry, we should return this. No, sorry. Sorry, we should return O. I was now thinking that we're in the mapper, but we're of course not in the mapper, we're in the observable, right? So we're in an observable, and then we're saying pipe whatever results you have into this other observable, which happens to be mapper in our case, right? So you pass in this other observable, and then you say, okay, let me subscribe to myself, right? And when I'm subscribing to myself, the function, the callback that I'll subscribe is the emission function of this other observable, so that the other observable will emit whenever I'm emitting, right? So that means that if it's the mapper that we've been passed in, then that mapper will emit whenever I'm emitting. And so then we return this mapper that we just that will now also subscribe to events of this particular observable, or will now subscribe to, or will now we're returning the mapper that will emit the inner observable that will emit whenever this particular observable is emitting. So this means that it should work again, right? We have the three emissions, and so forth, right? So this actually works. Okay, so that's pretty cool. Now let's do the mapping part. Why? I mean, this mapper is completely useless. Again, like, it's just the identity observable, but that's not interesting. What we want to have is we want to be able to say something like this. I want to map using the function, when given an x, duplicate that x. When given an x, let's say triplicate that x, right? Or something like that. I don't know, something like that, right? And then maybe let's rename these. Let's say doubler, and then tripler, right? And so instead of copy 1, we have doubler here, and then instead of copy 2, we have tripler. Okay, that would be more interesting. Of course, we don't have any implementation for that. We've just changed the name, so there's nothing that's going on, right? But the only thing we have to do is that, I mean, we're passing in a function into the mapper through the constructor. The only thing we have to do now is to actually make use of that function. And where should we use that function? Right? Think about it. Of course, in the emission, right? Whenever this mapper emits values, instead of just emitting the value, what it does is that it emits the value ran through the transformation function, ran through the function that we've been given, right? So we have, the mapper is given a function, right? And its job is to apply that function to all of the values that come through it. And whenever it wants to emit a value, then it applies the function, and then it emits the value. So if we do that, and then run this should actually work, right? Which it does. We have this very strange order, but we first have the original value, which is 10, and then we have the doubled value, which is 20, and then we have the tripled value, which is 30. And here we have the original value, which is 1, the doubled value, which is 2, and then the tripled value, which is 3, right? So actually, let me use a few numbers so that it's not as huge. So let's only emit 10. Let's say let's emit 10, -1, and then 1, right? So let's run that. You can see 20, 30, 10, -2, 3, 4, and then 2, 3, 1. Oh, sorry, I said 2, 3, 4. I meant -2, 3, 1, of course. Oops. For background. Okay, and then 2, 3, 1, right? So that still works. So now we actually have mapper, right? That's actually pretty cool. Now, this isn't very much of a pipe, actually, because this is more like, it's like a pipe where, I mean, if you think about it sort of as in terms of sort of a duality, if there's some kind of duality between observable.pipe, between like observable.prototype .pipe, is that like roughly equals to, I'm just expressing this as a comment, right? It's sort of roughly equal to the functional equivalent pipe. I mean, they're really not, right? Of course, they're different in many senses, especially since the piping here, the observable pipe takes a structure, an object rather than a function, which is a huge difference, right? And actually a very important difference, which actually makes me kind of sad in the heart. So if you're from, again, like if you intimately know RxJS, and you know that this is not the case in RxJS, please do shoot something in the comments. I'd be very interested to know whether RxJS actually sort of has the power of normal function composition, right? Like composition of actual functions, rather than composition using a special composition operator, which we are doing here, right? We're defining a special composition operator, and then we use that to compose objects. I mean, it's composition, right? But it's not as it's not pure function composition, which is cooler, right? I think maybe callbacks solve this. I don't know, maybe. But again, like if you've looked at lenses, for example, like it's trivial to build lenses that compose using a special compose operator. But that's not like the real power of lenses. Like the real power of lenses comes when you actually make lenses composable using normal function composition, and that's much more difficult. But anyways, that was a side note. Okay, let's keep going here. So my point is that maybe we actually want to be able to do something like this, right? Let's say let's say double then add 10, right? That's a pretty stupid pretty stupid thing, but whatever, right? So we want to say we have this observable and we want to pipe through two things. We want to first say, I want to pipe it through a mapper that doubles the value, but then I want to take it through a mapper that adds 10, right? And of course, I mean, this is silly because I could just put both operations in the first mapper, but you have to sort of cut me some slack here and realize that I'm trying to emphasize that now we're talking about mapping because we only have the idea of a mapping, right? But you might have completely different things such as filter or such as scans or as reject or whatever, right? I mean, you might have a bunch of different things. So let's remove tripler and let's keep this double then add 10, right? And actually maybe we should say like there's math abs in JavaScript, right? Like if we say math abs -10, yeah, we get 10, and if we say 10, we get 10. Okay, so abs is probably a better example, right? So let's say double abs, right? So first we double the value, and then when given some x, we take the math abs of that x, right? And then this should probably just be written as math.abs. That should be the same thing. Okay, so how do we do this, right? Now this is trickier because now we have two observables that we need to respect, and actually this original thing needs to work as well because that's a valid syntax as well. I mean, if I express that, like, let's line break that in a similar way. It's just that here we have one argument, but here we have two arguments. And actually think about it, we wanted to get to this point, so this is pretty close, right? It's just expressed in a slightly different way. Like if I uncomment this again and show this, it's like we have pipe, and then we have this thing, map molt2. Actually, let's do that first, right? Let's comment out this double abs and let's remove the subscription to tripler because now we no longer have that. Let's look at this one first, right? How could we get to this? Let's say doubler 2, right? This would fail, right, if I tried to run this, because we have, oh, actually, it fails for different reasons. It fails because of syntactic error. Where's the 46 here? Yeah, okay, sorry, I must have accidentally pasted some code here. Let me just try to undo backwards to see if it was any time recently. No, okay, it was a ton, super long time ago. Let's go forward again. Okay, so I messed something up here. Sometimes I accidentally paste stuff. Okay, so something like that seems to be where we were at before. So let's just, yeah, okay, now we have a syntax error, but because, or not a syntax error, we have a error, but, or like a parse error, but for the correct reason, right? It's like map is not defined, right? They're saying map here is not defined. And maybe we shouldn't call it map because it's not like functional map. Again, like we're talking about this special form of map, which is an observable map. And this is again back to the point of that this is not super. Like in an ideal world, we would want to use sort of the regular functional programming ideas such as map and reduce and all that stuff, and not sort of a duplicated implementation of map that's on the data structure observable. But then again, I mean, maybe that's sort of the way we have to do it, right? It's like an observable is a mappable data structure, so then an observable is a functor, right? You can map over an observable. So what do? Well, let's say that we namespace. Oops. So let's say that we namespace this mapping function to rx.map, right? I mean, the implementation of rx.map is like really simple, right? Because that's just saying, let's say we have a namespace called rx, and rx.map should be a new mapper. Oh, sorry, map needs to take a function, and then it returns a new mapper that runs this function, right? So this rx.map is just an alias, right? It's just an alias for constructing a new mapper. So instead of saying new mapper, we could say rx.map. It doesn't really matter which way we choose, right? But that works. And then this molt should work because that's the implementation we've built before. Let's just see if this runs, right? That seems to run. Let's see if it also does something. So let's say instead of running the doubler here, we run doubler2, right? Let's run that. You can see we get the same results in both of these cases, so that seems to work. I have to let the cat in. All right. So yeah, I mean, that seems to work, and that's just sort of an alias. And I don't know. I mean, we really don't necessarily need that, but again, like it's easier to like if you think about this, like rx.map is actually a function, whereas new mapper is not a function that you could put inside of a variable without instantiating it. So it's in some sense, from a composition point of view, it's better to have this thing called rx.map because that's like a first-class function. So let's copy this stuff and let's move it up to our observable library, right? Because this is now part of our observable library, and we could now I just created this new module Rx. We could of course have put map on the mapper, and then maybe we could have just done this. We could have said that the mapper has a static function called map, which takes some f and then returns a new mapper with f, right? So it's just a static way of invoking the constructor of mapper, right? So yeah, I mean, up to you. Maybe you prefer this, but I'm thinking we should put I'm thinking we're gonna put it like this because then I'm gonna put all of them like this. Like let's say we have filter over a function that's gonna return a new filter of f, right? Something like that, right? But one step at a time. So let's remove this static function. But you could definitely do it the other way. So where were we in the end here, right? Let's see. Does it still work? Yes. Okay. Let's remove this doubler. And let me actually, for the sake of simplicity, let me keep this inline function, because I think maybe it's like, in order to think about fewer things, maybe it makes more sense to keep this rather than invoking or passing the partially applied function molt, or molt applied to 2. So let's remove this 2 here so that we're calling the doubler again, and let's just run this to make sure that it's still okay. Okay, it's still okay. So the goal now is we want to get this thing done. So, but actually we're at 30 minutes, so I think we're gonna cut here. This is the goal for the next time. The goal for the next time is we want to get piping done. We want to be able to pipe not through a single other observable, but through a series of observables. We want to say, like, think about the syntax, right? We want to say double abs is the result of saying, or rather, double abs is an observable that is the result of piping whatever the original observable emits first through this mapper and then through this mapper, right? And these are going to give us observables, and then we want to create this sort of aggregate observable that is the result of first running through the first one and then running through the second one, and then we get back values. And when we're at that point, then we are like, we have some real power and can do some real crazy stuff, because then we can start to do filters and like scans and all that crazy stuff. So anyways, thanks a ton for watching. You know what to do, and let me know if you have any quirks, or like if you think I should approach things differently, or if you appreciate the series or whatever. Thanks a ton for watching. I'm glad to have you around. I'll see you in the next one.